Our fourth and final lesson in Unit 2 is actually going to be split into two parts. There's not a ton of new content here, but in order to do Lesson 4 well, we sort of have to spend some quality time reviewing some basics from Algebra 1. This might seem like a breeze for many of you. Others, it might just be rehashing whatever struggles you had over the last 2, maybe even 3 school years. And so I want to make sure that this is as accessible as possible, as palatable as possible. I want you to be as successful as possible, but that's going to require me to do a little bit of your Algebra 1 teacher's work, right? The work that they did for you in your pre-algebra teacher to make sure that we can understand, if we're going to apply the slope to situations involving parallel and perpendicular lines, we need to understand what slope is, and we need to be able to write equations in order to do these things. So this is really the focus of the lesson, but it requires that we have some background knowledge, which you have, but you just might not remember. So I'm going to hold you to account on that, but in order to make that as successful as possible, we're going to have to review. And so this is basically our review lesson. We know that through any 2 points, there exists a line. We learned that in our very first lesson together. And in Algebra 1, we explored that geometric concept by plotting 2 points in the coordinate plane and finding the equation of the line that connects those 2 points. And that equation is y equals mx plus b. We find the m value, the slope, which is again how steep the line is. Is it increasing fast? Is it increasing slowly? Is it not increasing at all? Is it decreasing a little or is it decreasing a lot? And so we talk about rates of increase and decrease of the line. That's the slope. And the slope, we typically use the letter m to denote slope. That's the rise over the run, or the change in y over the change in x. In calculus, they write dy dx. Which calculus is all slope, so you already know how to do calculus. It's kind of awesome. And you find the slope by subtracting the y values and dividing that by subtracting the x values. Okay, the difference in y is divided by the difference in x. The dy over dx. Difference in y is divided by difference in x's. The order here matters, and so I want you to do a good job of using the formula correctly. All right, if you're not using the formula correctly, you're setting yourself up for failure. If you follow the directions and you put the numbers in the right spots, your calculator and your brain can do all the work, all right? We just want to make sure that you put the things in the right spot. It's like those little puzzles, like, you know, the round one goes in the round hole. That's exactly what we're doing here. Special cases, positive slope versus negative slope. Positive slope means it's increasing from left to right. We always read a graph, left to right, just like we read a book or a sentence, left to right. Decreasing is a negative slope. If it's going down as you go from left to right, that is a decreasing slope. Horizontal lines have no slope, meaning that the slope is 0. There is no rise, it's all run. It's going to go left and right, but it's not going to go up or down. Whereas vertical lines have an undefined slope. Back when I was in school, they said it has an infinite slope. It's an infinite change because there's all rise, but there's no run, and we can't divide by 0. So the slope approaches infinity, approaches infinity, approaches infinity. The slope's really undefined, all right? Undefined is how we say that. So no slope and undefined mean different things. There is not a slope that we could define for a vertical line, but the slope is actually nothing. It's actually 0 for horizontal lines. I hope that that's not confusing, but they use that verbiage in Algebra 1, so we're going to use it here in geometry. Find the slope of a line given 2 points. So write down this example. Right? Again, the expectation is that you're writing down the examples and the information, and if I ask you to do examples, that you do those also. So you get to do a lot of work. We've got 2 points, A and B, and we are going to find the slope of this line. We're going to start by writing our formula down. And along the way, you might want to reference the fact that this is the first x and this is the first y. That this is the second x and this is the, second y. If you can identify x and y in your x comma y's and which one is first and which one is second, then you can put these numbers into the right places. That's all that there is. It's just a straight follow directions. Let's make sure that those numbers go where they go. y2 minus y1 divided by x2 minus x1. When we do that subtraction, we're going to get 10 over negative 5, which is going to equal negative 2. So our slope is negative 2. The slope of the line that has points A and B is negative 2. Down 2 over 1, down 2 over 1, down 2 over 1. So here, if we switch the order, so here I did B and then A, there's A then B, here I do B then A, please write this down as well to show, or summarize it, to show that if I do this as x1 and this is y1, this is x2 and this is y2, it switches both places so that now I get a negative 10 over positive 5 instead of a positive 10 over negative 5. I still end up with the same answer. I still end up with the same answer, whether it's A then B or B then A. But you do have to be consistent. It doesn't matter which one is the first point or the second point, but I would just label them, well, this is the first one that's listed, that's the second one that's listed. The key is that it doesn't matter at the end of the thing, all right? As long as you're following the steps, you're doing great. All right, the slope-intercept form for a linear equation, we write y equals mx plus b. That is not a new concept. Here, the slope is the m value, and we know how to find that. We just practiced it, right? B is not the y-intercept, all right? Your teacher lied to you. B is not the y-intercept. Y-intercept is a point where the graph crosses the vertical or y-axis. So that point is always listed as x comma y. The thing is that the x value is always 0, and b is the y value of the y-intercept. This number here is that number there. And so that's why sometimes they say b is the y-intercept, but that is false, that is not true. All right, 0 comma b is the y-intercept, that's a point. The y-intercept is a point where the line crosses the y-axis, so we're going to write our points as x comma y. The recipe or the formula that we will use to find our equations is written here. Y minus y1 is equal to m times x minus x1. So these are the variables. Y equals m x plus b. All right, there's no b in here. Instead of b, I have x1 and y1. All right, the x1 is going to be multiplied by m, and then we're going to add the y1 to both sides. All right, m is the slope of the line, x1, y1 is a point on the line, y and x here are just variables. So it's tough sometimes for students to distinguish the fact that this is a variable y and this is going to be a number y. This is a number for the slope, this is a variable for x, this is a number for x. All right, and so that might be tough initially, but after we've done a couple examples, you should be fine. And after you do this a lot of times in class, you should be fine. And especially if you've done well with this in Algebra 1 and you love Algebra 1 and you miss Algebra 1, today's your day. So let's write the y equals mx plus b equation for the line that has those 2 points. Well, line AB, we've already found the slope. We've already found that slope, and that slope we determined was -2. You do not need to rewrite that, but you should write m equals -2. Please write m equals -2 here. We've already done that work. But now we're going to use that formula. Y minus y1 is equal to m, which we know what that is, times x minus x1. We know x1, we know y1. Remember, we found m earlier. We are given x1 and we are given y1. And so we want to make sure that we use those numbers in this formula, and we can find out that y minus -9 is equal to -2 times x minus 4. I can distribute that -2 x's, +8, minus a negative is like adding. Now I'm going to subtract 9 from both sides, all right, or add -9 to both sides, and when I do that, I'm going to get y equals -2x minus 1. So this is the y equals mx plus b, right? 0 comma -1 is our y-intercept. This is our y equals mx plus b equation. Now, I do want to show you before, when we switched these, it didn't change the slope. It just kind of changed some of the work along the way. But we still ended up with, it was -10 over +5, and we still got -2. I want to show you that if I use the x2 and the y2, x2 and y2, it still works. All right, so write this down, please. Include this in the notes. Pause the video if you need to. But I want you to write in that it works for point B also. Because there's only one line that connects those 2 points. And it's this line, the opposite of 2x minus 1. All right? So it'll be the same equation regardless of if we use this point on the line or this point on the line or a different point on the line. Write the y equals mx plus b equation of line CD that has these points. This one right here, I want for you to try. All right? You are going to do the Algebra 1 here. If you are struggling with that, I want to invite you to go meet your Algebra 1 teacher. All right, and they can be like, we did this last year, man. Or come visit me during seminar. But if you can write that equation in y equals mx plus b form of the line that has these 2 points, then you should be good to go. You're going to find the m, and then use the m along with the x1, y1 to find the equation of the line, y minus y1 equals m times x minus x1. With respect to horizontal and vertical lines, all right, we already talked about how horizontal lines have 0 as their slope, and vertical lines are undefined in their slope. The way that we write our equations for our horizontal line is we understand that since the slope is 0, the y-intercept gives us the equation of the line. If the line crosses at 5, then that means y equals 5 always and forever. And so we can write that equation just by knowing where the line crosses the y-axis. All right? What's important about the equation of the line y equals 5 is that at -5 for x, y is equal to 5. At -4, y is 5. At -1, y is 5. At 0, y is 5. At 10, y is 5. At 20, y is 5. So the equation y equals 5 says it doesn't matter what x is, y will always be 5. For a vertical line, our slope is undefined, and so we can't use the y minus y1 equals m times x minus x1 formula, which is a lot of work anyway. Don't do all that work over here. But if we have a vertical line, if we know that the slope is undefined, right, where your change in x is 0, then your equation is just x equals the x value of the x-intercept, all right? So this would be a vertical line, so if x equals -4, then when x is -4, y could be -5, it could be -2, it could be 0. At x equals -4, it could be 10, it could be 25. And so what that's showing is that at every certain point, every single point on that vertical line, x equals -4, x equals -4, x equals -4. So that's the equation of the line. So let's write the equation. Actually, we're going to split this up. I'm going to do a couple of these, and you're going to do the other ones. Write the equation of the horizontal line that passes through this point. Horizontal is a y equals format. Vertical line is an x equals format. So what does y equal? Well, this is x comma y. So what does y equal? Y is -9. If this is x comma y, then what does x equal? X equals 4. There's no work to do. This is a conceptualization. Either you understand it or you don't. So this, if that's something that I haven't communicated well or well enough for you, let me know. If your Algebra 1 teacher didn't communicate that well or well enough for you, then let me know. You may need to make a flashcard just to remind yourself that the horizontal line has 0 slope and it's a y equals, that a vertical line is an undefined slope and it's x equals. There's a little mnemonic with that we can talk about in class. But I want for you to try these two. Write the equation of the horizontal line that passes through point B. Write the equation of the vertical line that passes through point B. Folks, that is the end of this introduction, this review of some Algebra 1 content. All right, there's a lot of things happening in there. There's a lot of steps. But this is work that you have done before and you can do.